Good afternoon, everyone. Today we will continue with the solution of linear differential equations. In this case, we will go with a simple example of non-homogeneous system of linear differential equations. Let's go to the blackboard. This system can be equivalently written like this, can be written like a system, well, a matrix multiplication of 0, 1, minus 1, 0 times the vector x plus a non-homogeneous term, which is b of t, that we know that is equal to 0 and 2. So this will be our non-homogeneous term. Let's write it here. So we saw previously that the solution of a homogeneous system with initial value, well, let's write the initial value here, which is x evaluated at 0 is equal to the vector AV. Right, we saw earlier in a previous video that this system had a solution which was given in terms of the exponential of t times the matrix A multiplied by the initial value. So now we generalize this system to a non-homogeneous system, and the solution will be a little more complicated, but it's also similar to the solution of systems with only one unknown. I mean a system like this. Let's say y prime is equal to ky plus a function of t. So this has a general solution that we saw previously. Some solution that is in terms of the integrating factor, which in this case is kt times the initial condition plus integrated with minus kt times. So we know this. Now we will try to apply the formula that is similar to this, but for matrices. So the formula is the following, which is similar to this one, but it also has some differences, which is like this. Now this is matrix, the exponential of a matrix. Let me highlight this. So this is the formula that you need to keep in mind. So in our problem, you know that this is A, this is B. Then the first step will be, of course, to calculate the exponential of this matrix. So we will go with that solution. You know that the matrix C is this one. The first step is to calculate the eigenvalues. So the characteristic polynomial of the matrix A is given in terms of this determinant, which is equal to a quick calculation give us so we multiply this by this and we subtract this multiplication, which is this. So Gamma has a complex solution. Gamma 1 is a complex number which is minus, well, it can be I, and gamma 1 is its conjugate, which is minus the imaginary unit. So this is it is more difficult than the previous case in which the eigenvalues were real numbers. This is the complex eigenvalue. The solution is, however, not too much difficult. In this case, the Jacobian matrix will be equal to, this is a notation, and this is equal to minus b. Oh wait, b and minus b. So in fact, you identify these a and v terms. This is the real part of some of these eigenvalues, and this is the imaginary part. So just to give the general solution. In this case, this wasn't even necessary to start with, because the matrix A already has its Jacobian form, because A is equal to 0 and V is equal to 1. If you take gamma to be this one, right? So it wasn't even necessary. This matrix is already written in its Jacobian form, and it can be proved that the exponential of the matrix I sub 2 A and V is equal to so this is a proven property. It can be proven, it can be shown that this holds. So what we need to do is to replace, let me add another one, to replace the values that we have here. So A is equal to 0 and V is equal to 1. So, and we can multiply this by t, and you can see if you multiply this by t, so it will be t in every entry. So t and t. So we go and replace A by 0 and V by 1, and you will have the exponential of 0, which is 1. So this will be equal to a matrix of the cosine of t, sine of t, minus sine of t, and cosine of t. So this is a matrix. So this helps us to calculate this. We have this. Now we need to calculate this one, but it is also trivial. You just need to, well, because the initial condition is 0, t sub 0 is equal to 0. So this term is 0, so it's the same. So we have this already. We also have this, and it remains to calculate this one. But if you have a minus t or t, it's all the same. Just change the sign of the expression. So we will copy this equation down here and replace these values by the matrix that we have calculated. So that goes there, and this is here. And now we know that this can be quickly calculated. You just need to change the signs in each case. All right, now we replace the non-homogeneous term, which was this one. It's a vector with 0 and 2, so we replace it here. We can replace the initial value, which was a and b. Now, this product will give us a column, which is this times this, so it will be 2 times sine of minus s and 2 times cosine of minus s. D of s integrated from here to here. But you also know that these trigonometric functions have some properties of parity. Sine if an odd function, and a cosine is an even function. So sine of minus s is equal to sine of s of minus sine of s, and cosine of minus s is just cosine of s. Now let's leave it there. All right, so to integrate a row, a column, you can just integrate each entry. So this is equal to integral of, let's put a coefficient outside, of sine of s ds 2 times the integral of the cosine of s. So this is all multiplied by this. Copy it here. So this is equal to the solution. Now, this integral is also very easy to calculate. This is the minus cosine of s evaluated in t0, t, and this one is the sine of s. So this will be in turn equal to minus cosine of t, minus minus is plus cosine of t sub 0, but t sub 0 is 0, so it's the cosine of 0. And down here it will be the cosine, the sine, the sine of t minus the sine of 0. And you know that the cosine of 0 is equal to 1, so this is 1, and the sine of 0 is 0. So we perform this. Let's copy it once again, just to have everything clear. This column will be minus 2, let's multiplicate, 2 times cosine of 2 minus 2, and down you have 2 times sine of t. So this is already the solution. You can write it, you can do the operations, or you can leave it as it is. It's already, there's nothing else to integrate, so it's pretty much done. But let's just do the calculations. So this product is equal to a cosine of t plus b sine of t, and the other is minus a sine of t plus b cosine of t, and this is plus this product, which is cosine of t 2 times cosine of t minus 2 plus 2 sine square of t, and the other one is minus sine of t 2 times and plus 2 times sine of t cosine of t. So you're summing these two columns. You can just sum them here, subtract them here. Let's put it a little more nicely. So this is the result. The first entry will be the solution of x1, and the second the solution of x2. So this is the general solution. It is very complicated. In fact, not a lot of things cancel each other. I mean, you can perform this multiplication. Well, you can do it 2 times cosine square of t minus 2 times cosine of t. Yeah, so this one and this one cancel each other. You have 2 minus 2 times cosine of t. Perhaps this is more nice. And then here is minus 2 times cosine. Yeah. So this one cancels with this one, and you're left with plus 2 times sine of t. So this is equivalent. So yeah, nothing else to do, I think. Is equal to yeah, this is pretty much it. So let's do a review. The first place is to identify the matrix and its non-homogeneous term, which is done pretty easily. And the second step is step 2 is to remember this formula, which is very similar to the formula that we already know for one unknown. The second step is to remember or to recall this property, which is important to have in mind, about the exponential of matrices of this form, A, V, minus V. So you have to keep this in mind. This is just a property. And after that, the remaining are trivial calculations. And so this will be the solution. If you have any questions, you can ask it down in the comments. I will try my best to answer them. Also, if you are interested in another topic, let me know and write it also in the comments. See you around.